Assalamualaikum and good day everyone. This video will cover on part 3 of structured chart and ERD topic. This part will focus on ERD topic which consists of ERD basic concepts and DFD and ERD. Firstly, we discuss on what is ER diagram. ERD, also known as ER model, is a type of structural diagram for use in database design. It is used to define the data storage requirements. Data storage requirements include the data entities, their attributes, and the relationships among the data entities. Okay, next we discuss on the basic concepts of ERD. For your information, the things that you need to know in order to construct or create the ERD are as follows. First is entity type, which represents a group of things or objects with same properties identified by enterprise as having an independent existence. We identify each entity type by a name and a list of properties. Example of entity types are student, subject, and lecturer. Second concept is entity occurrence or instances. Entity occurrence is a uniquely identifiable object of an entity type. Okay. A third concept is relationship type. Relationship type is a set of meaningful associations among entity types. Each relationship type is given a name that describes its function. It expresses how entities are mutually related and always exist between two entities. Okay, next is relationship occurrence concept. Relationship occurrence is a uniquely identifiable association which includes one occurrence from each participating entity type. And next is degree of a relationship. Degree of a relationship is a number of participating entities in relationship. The first relation of degree is binary. Binary relationship means two different entities are connected to one relationship. For ternary relationship, we have three different entities connected to one relationship. And for quaternary or n-ary relationship, we have four or more different entities connected to one relationship. Okay, next concept is attributes. Attribute is a descriptive property or characteristics of an entity. For example, a student entity type may be described by the student number, name, address, and phone number attributes. There are many types of attributes such as simple attribute, composite attribute, single valued attribute, multi-valued attribute, and derived attributes. Okay, next concept is key. Key is an attribute or a group of attributes that assumes a unique value for each entity instance. It also known as an identifier. There are many types of key such as candidate key, primary key, foreign key, and composite key. Next is generalization concept. Generalization is a process of minimizing differences between entities by identifying their common characteristics. Okay, next concept is supertype or superclass. Supertype or superclass is an entity type that includes one or more distinct subgroupings of its occurrences. And last concept is subtype or subclass. Subtype or subclass is a distinct subgrouping of occurrences of an entity type or an entity whose instances may inherit common attributes from its entity superclass or supertype. DFDs and ERDs are both used two model systems, but they show two very different perspectives on the system. Generally, we can say that a DFD shows what the system does as well as the data that the system manipulates, and an ERD shows only the data that the system manipulates. This slide shows the differences between DFD and ERD. As you can see here, DFD shows how data enter a system is transformed in that system and how it is stored in its. And ERD represents the entity model and will show what a system or a database will look like, but not explain how to implement it. Next, DFD shows what things or procedures transform inputted data into some output as well as where data is stored. While ERD model what kind of data and what relationships do different pieces of data have with each other. It would define the structure of our database tables. Okay, next. DFD main objective is to represent the processes and data flow between them, while ERD main objective is to represent the data object or entity and the relationship between them. Okay, next. DFD explains the flow and process of data input, data output, and storing data, while ERD explains and represents the relationship between entities stored in a database. Okay. DFD is usually processed individually based on certain aspects where each of them could be linked interactively, and ERD often represents a group of similar things. It shows how the data units are grouped into entity logically. Okay, lastly is DFD is not enough to completely describe a system. It can also specify computations in a process, while ERD does not show the interaction between the model or data and how it changes in a system. This slide shows the example of DFD and ERD. Okay, next we discuss on when should such a chart and ERD be used. Okay, when we want to design a program code, usually we will transform logical DFD to be to a set of structured chart. From a structured chart, we can write a pseudocode or draw a flow chart before to start programming. And we use ERD when we want to design database. From DFD, we have many data storage elements which will made to be automated. We use ERD to design database for them, meaning how to systematically store all data as computer format. I think that's all for the structured chart and ERD topic. Thank you.